we have a logical equivalence that says P or Q is equivalent to Q or P. And it makes sense that these are equivalent because the result of an OR is true if at least one of the inputs is true, so it shouldn't matter which order I give the inputs in. And this is analogous to a rule of algebra that says that A plus B is always equal to B plus A, whatever numbers A and B are. This rule is called commutativity. And commutativity of an operation like or plus says that the order of the inputs to that operation don't matter, you'll get the same result either way. Or and plus aren't the only commutative operations. We also know that times is commutative because A times B is always equal to B times A. And in propositional logic, or is not the only commutative operator. P and Q is logically equivalent to Q and P. Also, P if and only if Q is logically equivalent to Q if and only if P. And both of these should make intuitive sense, and is true if both of the inputs are true, so it shouldn't matter which order I give the inputs in. If and only if is true if both of the inputs are the same, so it shouldn't matter again which order I give them in. There's another sense in which it doesn't matter what order I give inputs. So it's not just that I can swap the inputs of the operation and get the same result for plus, but also if I have multiple plus operations, like A plus B plus C, then I can choose which order I do the addition in. I could choose to do the A plus B first, or I could choose to do the B plus C first. And either way, I'll get the same answer. And this rule is called associativity. And again, not every operation is automatically associative, but some operations we know are associative, such as times. A times B times C is always equal to A times B times C. And we might ask, are any of the propositional operations associative? The answer is yes. It's actually the same three. P or Q or R is logically equivalent to P or Q or R. P and Q and R is logically equivalent to P and Q and R. And these are pretty much for the same reason as these operations are commutative. An OR is true if at least one of the inputs is true. So if one of these three is true, then one of these three should be true, and vice versa. And is true if all three of the inputs here are true, and that's the same on the right-hand side. It turns out that if and only if is also associative, which is less obvious, but we could use a truth table to check that P if and only if Q in brackets if and only if R is logically equivalent to P if and only if, and then in brackets Q if and only if R. There's another rule of algebra which also has an analogy in propositional logic, which is multiplying out brackets. If I have a formula like A times B plus C, then this is always equal to A times B plus A times C. And there's an analogy to this rule which is called distributivity in propositional logic. In this case, we might say that multiplication distributes over addition because the times is on the outside, so I'm multiplying out the brackets which have a plus inside. And it happens that AND is just distributive over OR if I have an AND on the outside of the brackets and an OR inside the brackets, and that's logically equivalent to, I might say, ANDing out the brackets, or doing an AND with P of each thing inside the brackets, so P and Q, P and R, and then if I put brackets around these, then I had an OR inside the brackets, so I can put an OR here. And it turns out that these two are actually logically equivalent, which tells me that P and Q or R is always the same as P and Q or P and R. And that means that AND distributes over OR. Now there's another case of distributivity in propositional logic, which is that OR distributes over AND, which might be a bit surprising because I don't have a similar rule in algebra. I wouldn't be able to plus out some brackets like this, if I have a plus b times c, then this is generally not equal to a plus b times a plus c. But in propositional logic, it is the case that p or q and r is logically equivalent to p or q and p or r.